Retroviruses. What are they?
How do they work?
And how do they interact with DNA?
Soon, you'll know all of this and more.
Cue the music.
We don't have music.
Let's start with the basics. What is a retrovirus?
A groovy virus from the 70s?
Unfortunately, no. To find out, let's take a look at the word. A virus is a pathogen that can't reproduce on its own. It has to use living cells of its host to do so. That's simple enough. Retro is a prefix meaning reverse or backwards. But what does that mean for a retrovirus?
I know the answer to that. Retroviruses, which look like RNA, can actually rewrite DNA thanks to an enzyme called reverse transcriptase. Remember gene expression? Well, apparently retroviruses don't.
When scientists discovered retroviruses back in the early 1900s, the central dogma, the belief that information flowed from RNA to DNA, was challenged.
Speaking of their discovery, how are they discovered?
Chickens! Yeah, chickens. Imagine you're a scientist in 1908 researching neoplastic diseases in chickens.
Neoplastic?
Neoplastic diseases involve abnormal cell growth, like in a tumor. Back to your chicken research. You two finally realized that the pathogen causing chicken leukosis is something you've never imagined, a retrovirus.
Was that poorly executed flashback really necessary?
It was completely necessary. Speaking of the history of retroviruses, let's talk about something we humans love to talk about, ourselves. Did you know that about 8% of the human genome is actually composed of retroviruses?
Whoa, I didn't know that. That's crazy.
Well, now you do.
Let's talk about how these retroviruses do their job in style.
So, how do the genes that I talked about have a role in all of this?
Well, the genes within viruses are encoded in RNA instead of DNA. All viruses use cellular machinery to infect the future copies of themselves.
What makes retroviruses so special then? Isn't that just a normal virus?
Hold your horses, Kevin. Remember how Neha talked about that enzyme called reverse transcriptase? Reverses viral RNA into DNA. An extra step called backwards transcription not found in normal viruses.
But how does this newly created viral DNA infect the other cells?
For the first cell to be infected, another part of the retrovirus is called integrase. It must break apart the newly made viral DNA strand so that it can bond with a strand of its host DNA. Then, after the first cell is infected, the poor cells are tricked into copying infected genes when following through with their everyday replication process. It happens like this. The single-strand viral RNA forms an infected double-strand DNA. This viral DNA is then able to be copied and replicated.
Okay, Maddie, these retroviruses seem pretty harmful. How can we prevent them?
I'm sure you've all heard of HIV. You know, that one immunodeficiency virus you get from infected blood and unprotected sex. It can then turn into AIDS, which has no cure and could lead to death. Yeah, we may want to prevent against that. That's why the amazing world of science has created reverse transcriptase inhibitors! Yay! These inhibitors can be found in many classes of HIV drugs and act to prevent the integration of the infected genome into host cells, which in turn slows the progression of the infection and stops cells from continually copying the viral DNA. It's a win for all.
Except for those groovy retroviruses.
Now that we've learned about what retroviruses are and how they work, let's talk about the consequences of their interactions with organisms.
They're viruses, so everything they do is evil and bad, right?
Ha 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 ha. No, that is far from the truth, as retroviruses are very bad, but they are also very beneficial for humans and other organisms. The first one benefit of retroviruses is related to...
Okay, no need for the dramatic pause. Let's move this thing along.
Endogenous retroviruses.
What in the world are endogenous retroviruses?
I'm glad you asked.
No, you aren't.
Whatever. They help protect against their much meaner brother, exogenous retroviruses, which include nice fellows like HIV and AIDS.
Okay, that's better evidence than I thought you had, but is that it?
No. Retroviruses can also become so integrated into their hosts that they will eventually be expressed as new and useful genes.
I get it. But even with all this, I'm still on the fence about whether or not I need to put that Amazon Prime membership to good use and buy a hazmat suit. You know, to prepare for the impending retrovirus plague.
Okay, fine. What if I told you retroviruses are part of the reason we even exist today? Retroviruses are partially responsible for cellular differentiation and the development of the human placenta. Huh? What did I tell you?
Okay, maybe retroviruses aren't so bad.
Whoa. Did he just tell you that retroviruses are all good? Because I would like to point out that they are still very bad and are still very much a virus.
Oh man, I almost got away with it.
Got away with what?
My evil plan of presenting a scientifically biased opinion without giving the full story of someone's research, or at least presenting a viable counter-argument to my side of the story. Curses!
That was weird.
Agreed. But you were saying something about how retroviruses are also bad?
Oh yeah, well, first those endogenous retroviruses he was talking about, yeah, they aren't completely benign. They still have the potential to rise up and lay waste to your body as an infectious disease. Granted, this isn't likely to happen, but there is more. Retroviruses may be useful in some species, but if they're transmitted to others, they can be extremely deadly. For example, SIV, the primate version of HIV, is actually good for various primates like apes, but when the very similar HIV pops up in humans, it's extremely deadly.
If I were, in some weird way, to come into contact with an ape's blood, it would be Planet of the Apes?
Not likely. Anyway, one last harmful effect of retroviruses is that they can cause genetic disorders and malignancies in humans and other animals. In humans, the retrovirus HERVK can cause malignancies like breast cancer and prostate cancer.
I now think I have enough information to make an informed decision whether or not to buy that hazmat suit now, or when it goes on sale in December. Thanks!
No problem, I guess. Now, you've all learned a lot about retroviruses, but why should we care?
For one, HIV. As I spoke about before, HIV is a retrovirus that suppresses the immune system of its host, making the host susceptible to disease.
Retroviruses are also being tested on for gene therapy. Scientists have gotten diabetic rats to produce insulin on their own through retroviruses.
Wow!
We hope you learned something today about retroviruses.
If nothing else, know that they aren't a groovy virus from the 70s.
Thanks for listening.